period of first generation computer was in 1940 to 1956 using vacuum tubes. Hardware technology. First generation of computers started using vacuum tubes as the basic components for memory and circuitry for CPU, that is central processing unit. The input to the computer was through punched cards and paper tapes. The output was displayed as printouts. Software technology. The instructions were written in machine language with uses zeros and ones for coding of the instructions.
ENIAC stands for Electronic Numerical Integrator and Computer. It was the world's first large-scale digital electronic general-purpose computer. It was designed to be capable of being reprogrammed to solve a large number of numerical problems. ENIAC was conceived and designed by John Mauchly and J. Presper Eckert of the University of Pennsylvania. In 1997, the 6 women who did most of the programming of ENIAC were inducted into the Women in Technology International Hall of Fame. In addition to switch panels and wiring panels, ENIAC used an IBM punch card reader for input and an IBM card punch machine for data output. The timing of these machines was synchronized with the operation of the ENIAC itself. The ENIAC was a very large machine. It weighed over 30 tons. The ENIAC had a total of 40 panels and utilized 18,000 vacuum tubes, with 70,000 resistors and 10,000 capacitors. ENIAC also had its own dedicated power lines. To keep the vacuum tubes from overheating, the room was air-cooled. When ENIAC was announced in 1946, the news media called it a giant brain. Its computing speed was 1,000 times greater than that of electromechanical machines. The ENIAC's other applications included weather prediction, atomic energy calculations, cosmic ray studies, thermal ignition, random number studies, wind tunnel design, and other scientific uses. Here, output from one of ENIAC's printers is being produced. In this scene, we see brilliant ENIAC designers J. Presper Eckert on the left and John Mauchly on the right. They would continue their involvement in computer design and manufacture far beyond ENIAC in the years to come. Unable to reach agreement with the university, both Eckert and Mauchly left the Moore School in March 1946, along with many of the senior engineering staff. UNIVAC-1 was released in 1951. In 1955, Sperry merged with Remington Rand, and the name Sperry UNIVAC was used on many computers until Sperry dropped the name UNIVAC in 1984.
UNIVAC. Now, recent experiments show that future use of UNIVAC may give us faster and more accurate weather predictions than were ever possible before. You see, UNIVAC can take the past histories of thousands and thousands of storms, analyze them, compare them with developing conditions, and make predictions, all in a matter of minutes. Calculations that would ordinarily take hundreds of man-hours to complete. Data from guided weather rockets, radar observation stations, weather stations, all of this can be fed into the computer through these magnetic tapes at a rate of 12,000 numbers or letters per second. The memory tanks make immediately available 12,000 additional units of information. And all of this complex weather data is analyzed in the heart of the UNIVAC, the electronic central computer, capable of making over 2,000 mathematical calculations per second. Now, here is where we get the answers. You might call it the voice of UNIVAC. Actually, it's a high-speed printer that prints results at the rate of 600 lines a minute. So you can see that UNIVAC is both fast and versatile. But most important is the assurance that UNIVAC will give you the right answer. And that's made possible by UNIVAC's unique ability to check itself on possible errors. Let's watch right now as UNIVAC puts itself through one of these self-examinations. Here it is checking on some of its own units. It's really an amazing system, isn't it? Amazing and yet so wonderfully practical. Remington Rand makes 4 basic UNIVAC models. The general purpose UNIVAC, which you've seen tonight, UNIVAC Scientific, UNIVAC File Computer, UNIVAC Punched Card Computer. Each of them capable of literally hundreds of applications from weather forecasting to complete business control. Today, UNIVAC is saving time and increasing efficiency for science, business, industry, and government.
UNIVAC, the giant electronic brain made only by Remington Rand, takes business statistics from magnetic tape, letters, numbers, and punctuation marks, processing them through its electronic circuits at phenomenal speeds. UNIVAC can compute payrolls electronically, then produce printed checks in a flash. Over 8,000 checks an hour with this high-speed printer. UNIVAC leads the field of electronic computing.
This was the first in IBM's 700 series of high-speed computers and first in the line of IBM's commercially available electronic computers. 19 complete systems were manufactured beginning in 1952 and were typically rented for about $12,000 to $15,000 per month, equivalent to about $140,000 to $175,000 per month today. Designed primarily as a scientific computer, IBM 701 competed with the UNIVAC 1103, which had been designed earlier by Engineering Research Associates for the U.S. Navy. In tests requested by the Navy, the 701 demonstrated slightly faster processing speed, but had slower input-output than the UNIVAC 1103. Research indicates that 19 of the IBM 701 systems were ultimately manufactured, compared with about 30 or more of the competing UNIVAC systems. However, in cases where computers were manufactured for national security purposes, exact production numbers may not be publicly available. The 701 was a 36-bit, parallel machine, with internal binary operations. Shown here is a close-up of the 2 magnetic drums. This unit itself weighed about 1,500 pounds, providing about 82,920 digits of storage. You can see the switch on the left, indicating 4 logical divisions. A few words about the 700 series. Whereas the 701 was primarily designed for scientific and engineering calculations, including military, aerospace, energy and large data applications,